Transportation safety is related to everyone. A real-time data-informed crash prediction tool can provide transportation safety insights and life-saving solutions for not only traffic operators and decision makers, but also public users who are making safety choices every day. We will introduce the tools by user type. For operators, the main component is real-time crash risk prediction and visualization. Here is the whole picture of the system interface for operators. The side window shows different groups of functions which could visually assist operators to monitor the crash risk of the whole network as well as the corresponding real-time traffic status. This chart shows the top 5 high-risk freeway segments with the predicted real-time crash risk scores. If operators click any of the 5 bars, the map will zoom to the selected high-risk segment. Meanwhile, the real-time crash risk, speed, and volume of the selected segment could be visualized. Also, operators can switch to arterial to check the top 5 high-risk segments. In addition, operators can select a segment directly from the map. For example, if they select the high-risk interstate freeway segment, they will see the real-time crash risk as well as severe crash risk. They can also look at the speed and speed standard deviation from up and downstream. Together with the volume, operators will get a better idea about what is happening. For this high-risk segment, operators can use the AI tool to identify the best solution to mitigate crash risk. The AI recommended strategy in this selected segment is VSL and ramp metering. Operators can also see the simulation and animation to better understand how the suggested strategies could alleviate the real-time crash risk. At the same time, operators are able to access the real-time CCTV camera to check the field status. Also, they can check the historical implementation statistics of the current segment. Later, operators can download a regional strategy implementation report. This could help operators to better understand the recurrent high-risk segments and the most beneficial strategy. The system could adapt to new data inputs, for example, real-time GPS data from regional operated floating cars. We are able to monitor the real-time operation status of 56 campus shuttles, including their speed and location. In a connected vehicle environment, this shuttle could communicate with others within DSRC range.
Let's move on to the section for the decision maker. This section is based on historical data, and it has 4 components. First, the decision maker can look at a macro screening for crash analysis, which is at the zone level. Here, the zones are classified by zip code. Decision makers can check the crash frequency and rate by severity level, and they can see the map on the right side by clicking on the severity level. Meanwhile, decision makers can click each zip code area to see the severity distribution. With the same function, decision makers can also check the violation types. In addition, they can find the at-fault driver's residence. As a result, decision makers can target areas to educate for a particular violation. For example, if they want to reduce the DUI crashes caused by teenagers, decision makers can get the map of those teenagers' residence and overlay it with high schools to educate accordingly. The second component is a network screening for freeways, expressways, and arterials. The decision makers can check the crash by severity level and crash type. For a segment with a serious crash problem, they can check the countermeasures recommended by the AI system. For example, the AI recommends adding illumination to reduce the head-on crashes on the arterial. For arterials, social media data including Twitter and Strava are added. Decision makers can see people's concern about the pedestrian safety from Twitter. Meanwhile, Strava data shows bike activities to help improve bike facilities. The third component is a temporal heat map of crashes. It will help decision makers better target the problem based on the time of day. Lastly, there's a CAV component for the county level. Safety improvement by CAV is estimated from our research. For example, if 25% of vehicles are CAVs, one can expect around an 8% crash reduction.
Lastly, safety information is available for the public and it can be accessed by any user. This information pertains to crashes related to pedestrians, cyclists, and violations in their zone. If users click a region, they can see the heat map and severity level. For cyclists, bike lane information is included. The real-time traffic condition is provided. Finally, the locations of schools and hospitals are included for the convenience of the public. The team has been a traffic safety pioneer. We have spent over 20 years extensively researching crash occurrence factors and analyzing crash data from many states in the U.S. Based on these efforts, we have developed this visualization tool which uses real-time big data analytics, AI techniques, crowdsourced data analytics, etc. This tool will power road safety management with cutting-edge technologies and provide life-saving insights for each road user. Our system will play an important role in developing safer and smarter cities for the future.